Good morning to all. This is the day 2 of our Arduino lab session. So before start the day 2 class, I will recap your first class very quickly because some of them may absent for the first class. Please make a note of the few things and immediately we get into our day 2 class. Okay. Yes. Well, so we are going to use Tinkercad. Everybody knows. So using this cloud software, we are going to do the simulation. What we have did last class, first we made the personal account, then we did few experiments. The first one is blinking an onboard LED, the second one is blinking an external LED, then two LEDs in alternate fashion. Is it okay? Then, so this is our first experiment. We successfully made the onboard LED to blink for some time. So on for some time, off for some time. So we achieved that one. This is our very first exercise. Then the next one, only the hardware arrangements are different. The program is same. The same 13th pin is used to interface the external LED. The same coding. There is no change in the programming part. Only the hardware part we have modified. This is our second experiment. What we have did in last class. Then we made little modification in our second experiment as changing the delay times. That means there is a not constant on and off time. We modified the time as on time for 5 seconds and off time for 2 seconds. The beauty is without modifying the hardware circuit, just we modified the programming part alone. So those who are attended, they can understand this one very well. Then the last experiment was alternate LEDs blinking. So the animation is here. So the first we made one LED. So initial condition, there is no LED is on condition. It remains off. First we are going to make the first LED to on, or sometime after some time the first LED has to off. Immediately the second LED has to on. Then the cycle has to repeat. So using, I didn't show for loop function, but you people made it in this task what we have given. So the alternate LED blinking fashion we finished. Then this is your task. So nearly 25 students were submitted this assignment. Remaining students, please try it out. Today we are not going to disclose the answer. Once we finish, we will disclose our answer. Okay, so the 4 LEDs, once again I repeat this one. Those who are not completed, please try. Here we are not specified any pin number. You can use any 4-digit input output pins available in the Arduino in any fashion. Okay, now either see the animation once. Initially, all the LEDs in off condition. Then first LED has to on. After some time, immediately first LED off, second LED on. Okay, then second LED on for some time, then immediately off, then third LED. And third LED on for some time, then fourth LED. Again, the cycle has to come back. So initial condition, again first LED, second LED, third LED, fourth LED. Okay, try this one. If you are facing any problem, please contact us. Okay, good. Today we are getting into the day 2 class session. So what are the things we have studied so far? Can you type it in chat box? What are the new things we are going to interfaces today? Can you tell? What are the new things we have seen? So last class we have discussed only output device. Today we will learn one new thing. What? I hope you may type switch. Hello? Hello?
Switch type பண்ணிருக்காங்க இதுல.
Yes.
Switch and digital read type பண்ணிருக்காங்க.
Yes, very good, very good. So what we are going to do means today we are going to do 2 things. The first half is switch. Okay, I will show the statement what we are going to do. The interface, switch and LED. So last class we did only with LED. Now we are going to add switch. So switch, obviously switch is going to act as an input device because the no system have only output or only input. All the system must have an then a 1 or 2 input device and 1 or 2 output device. So if you want to control your output, you must have any input device. So what we are going to do with this? First one, if the switch is in on condition, make the LED to on, else turn off the LED. So we gave the problem statement as like your C program structure. Okay, you may understand what the structure we have to use. Already Sir have explained. So we are going to read the switch. If the switch is in on condition, we are going to turn on the LED. The switch is in off condition, we are going to make the LED to off. This is the first exercise what we are going to do today. And the next one, by reading the switch status, we are going to toggle the state of the LED. Please make a note of this problem statement. If the switch is pressed, toggle the state of the LED. I hope you may aware of the term toggle. Toggle means changing the state from one to another. In digital form, if my logic is 1, if I toggle, it will become 0. If my state is 0, if I toggle, the state will become 1. So 1 to 0, 0 to 1, likewise we are going to toggle. Okay. Toggle means what kind of output we can observe here means, if the LED is on condition, if I press the switch, it will make into off. If my switch is in off condition, if I press the switch, it will make it into on. So the alternate function we are going to create it. We will check it one by one. First we will enter into the first task. Interface, the buzzer we will come to later. First we will get into the first task. First problem statement, if the switch is in on condition, make the LED to on, else turn off the LED. Please observe the schematic diagram, what we are going to do with the Tinkercad. The same thing we have drawn here. So what are the things we need to include in our circuit diagram? One switch and LED and 2 resistors. You may be aware of this portion, why we are using LED in series with the resistor. Today we have learned why we are using resistor. So whenever we are using any input device, even to avoid the floating state, we will use one resistor. Okay, so there are 2 types of configuration. One is pull up resistor and pull down resistor. In our contest, we are going to use pull down resistor. That means always my port pin will be logic 0. Please observe the video. Can anyone tell what is happening over the animation? I repeat once again.
If possible, கொஞ்சம் zoom பண்ணினா பரவாயில்லை கஜேந்திரன். If possible, கொஞ்சம் zoom பண்ண முடியும்னா கொஞ்சம் zoom பண்ணீங்கன்னா கொஞ்சம் clear-ஆ தெரியும் பிக்சர் நகர்த்துறது.
Yes sir.
மொபைல்ல zoom பண்ணி பார்க்க முடியும் சார் ஸ்டூடண்ட்ஸ்னால.
They can zoom and see. Yes.
Yes.
சரி இவ்வளவுதான் zoom.
Okay, fine.
I hope you may type the answer. If my switch is in off condition, LED remains off. If I make the switch to on, LED gets turned. Yes, the simple thing, the same thing we are going to draw in our Tinkercad, and we are going to start type the program. Before that, I will show the already you may aware of the program. Let me recollect once. Immediately we will get into the exercise. See. An algorithm, see, it is a good practice, as Sir explained you earlier. Even in your C program, what you will do, first you will write the algorithm what you want, then you will write the required program. So the algorithm goes like this. So in void setup, what I am going to do, I am going to configure the pin number 4 as input. Why I am going to configure pin number 4 as input? Can anyone tell? Why we need to configure pin number 4 as an input? Why? Whether we are going to connect switch in the pin or LED in the pin. By the algorithm, you can say we are going to connect switch. Very good.
Switch.
Yes. Then configure pin 12 as output. Why pin 12 as output? Here I am going to connect my LED in pin number 12. So pin number 12, I am going to connect my LED. So I need to configure the pin number 12 as an output. These two statements you are aware. Immediately the one more statement. I am making the pin number 12 to logic low. Please make a note of it. Whenever you are using any output device, at initial condition, it must be in off condition. Please make a note of it. If I am making any system to work, if my power is off and immediately it comes again, my void setup program will run once. So whatever I am going to do is, if power interrupt happens, immediately if power comes, initially I am going to turn off the output device. This must please include in your program. Whenever you are going to configure any output device, in setup you make it as a low. Now we will see the program. You know how to configure the pin number 4 as an input, pin mode 4, input. Then configure pin number 12 as an output. The equivalent syntax is pin mode 12, output. So immediately I need to make the particular output as a low. So low means digital write 12, low. Is it okay for everyone? So void setup only 3 lines. Configure the pins and also make the output remain as a off condition. Here off condition in our state is low. So digital write 12, low. Then in loop, it is a continuous statement. So as Sir told in the first class, in a C program we may not have an infinite loop. Here you must have an infinite loop. So in your system 24/7 it has to monitor the pin number 4. Whenever you are pressing the switch, irrespective of the time, evening, morning, at any time, if you press the switch, I need to get the required output. So in void loop, only you need to read the status of the switch. Point number 1, read the status of the switch. Immediately, if the switch is in on condition, make the LED to on. Is it clear? Read the state, check the condition, make the LED to on. Then, if not, what I have to do? The reverse action. Else, make the LED to off. I hope you are clear with this. Now we will come to the program. Void loop. Here I am going to assign the variable as SW. As Sir told already, don't use inbuilt function as a variable. You may be aware of the inbuilt functions. So even digital read is an inbuilt function. Okay. So likewise, you are having number of inbuilt functions. Those inbuilt functions you should not use it in your program as a variable. Okay. Here I am going to use int switch as a variable. So I am going to assign the switch as an integer. Immediately I am going to read the status of the switch. Since I have connected switch in pin number 4, I am going to read the status of the pin number 4. I am going to store the status in my variable name called SW. Hereafter the things are very simple. I need to compare what I am going to compare with the logical state. So here I am going to compare with the logical statement as high. Can anyone tell why we are going to compare the switch into logical high? Can anyone tell what kind of resistor, what type of resistor we have connected in the 4th pin? Whether it is a pull-up resistor or pull-down resistor. Can anyone tell? We are having 2 type of configurations, pull-up and pull-down. And initially we told that we are going to connect the resistor in 1 type of configuration. Can anyone tell? We are going to connect the resistor in pull-down configuration. That means by default, my switch will read, if you read my switch status, it will be in logic low. If you press, the state will vary to low to high. Therefore, I am going to check the status as if my switch is equal to high means I turned on the switch. My system will recognize there is some change in the output external environment. Once it happens, immediately you can turn on the LED. Here we no need to write delay anything as like a blinking program. Simply you make the LED to on. Else part, can anyone assist what I have to type? Else part, else what I have to type? Same pin or different pin? Digital write off 12 comma, that's all. So this is only the program part. Immediately we are, if you have any doubt, please stop me, else I will continue with the simulation part. So those who are new to this class, first you have to type Tinkercad in your browser window. If you type Tinkercad, this home page will get appear. Then sign in. First time if you are getting entering it, you have to use join now. Okay, sign in. Sorry. So already if you are having an account, join now. Join. I think I am making mistake. Sign in. Sign in with the existing account. Already I am having a Google account, so I am going to choose the same account. So is it visible, sir? Can I continue, sir? Sir?
There is.
In this, by default, it will show 3D design. Make a change as circuits. I will repeat once again. By default, it will show 3D design. We change it as circuits. Then go to create new circuit. Press create new circuit. Here what we have to do in this new circuit, what are all the components we need to fetch? Please type it in chat box. Please help me. By the time the window gets appeared, please tell me what are all the components we need to fetch from the software. Please type. For today's exercise, what are the components we need to fetch? Please help me.
Switch,
Yes.
LED,
Yes, sir.
resistor,
Yes.
Arduino board.
Yes, very good.
Breadboard,
It won't take this much time.
நிறைய பேர் போஸ்ட் பண்ணிருக்கீங்க ஜி.
Yes, sir. Very good. Yes. So as you told, we need to fetch, before fetching the component, we need to relabel the XML. What we can type? Interface, switch and LED. Whatever the title you want, please keep it over there. Okay. And immediately, why we must have this practice means, if you forget to type the name means, in later session, if you want to refer your circuit diagram, it is difficult to check it. Okay. So here this is our workspace where we are going to keep all our hardware component and making the connection. This is the code window where we are going to start type our code. So the left hand side you are having components. It is best practice type where you have basic components and all. Please select all, then you will get all the components over here. Here you want to know about the particular device. What is this means? Please click this window. It will immediately here in only single component will get up here. The right hand side, you have a small description about the component. So what is the function of the component? You can check it. Okay, see, slide switch. A switch with two position, open or closed. Okay, likewise, you can see the individual functions of the components. Okay, so what are the components I need to fetch? As you told already, so I'm changing the option. First resistor. So step by step we will take. First we will take Arduino controller. First my controller. Please select the component and drag and drop in your workplace. Okay. Then breadboard we want. Breadboard. Then what else we want? Output device. Output device. What we are going to use? See, output device. LED. Then current limit resistors. Then switch. See, in this input option, please observe here in the input option, you are having variety of things. See, switches, simple push button, then potentiometer, slide switch. Too many components are available. In this class, we are going to see only these two, push button as well as slide switch.
கஜேந்திரன் ஸ்கிரீன் சரியா விசிபிளா இல்ல கஜேந்திரன்.
சார்
ஸ்கிரீன் சரியா விசிபிளா இல்ல கஜேந்திரன். ஏதோ ஒரு போர்ஷன் மட்டும் தான் தெரியுது. நீங்க பண்ற போர்ஷன் தெரியல.
சார் தெரியுதா சார்?
நிறைய பேருக்கு
போர்ஷனா இருக்கு இப்போ.
இப்போ என்ன இருக்குது? blank மட்டும் தான் இருக்கா?
ஆமா, பிபிடி தெரியல.
சார் இப்போ டிங்கர் கேட்ல மட்டும் தான் ஒர்க் பண்ணிட்டு இருக்கேன் சார்.
அந்த டிங்கர் கேட் ப்ராஜெக்டால.
சார் வெயிட் பண்றேன். எப்போ இருந்து தெரியல. சார் நான் ஃப்ரெஷ்ஷா ஷேர் பண்றேன் சார். 1 செகண்ட். Sorry, I don't know when I have.
இல்ல இப்பதான் அனுப்பிச்சது.
Is it visible now?
Yeah, now it is visible. Component எடுக்கிறதுல இருந்தே ஆரம்பிக்கணும். Component அவங்க எடுத்துவாங்க. நீங்க இப்ப component வைக்கிறதுல இருந்து ஆரம்பிங்க போதும்.
Yes sir, okay sir.
Component எடுத்துவாங்க.
I hope you how you
ஒரே ஒரு component மட்டும் எடுத்து காட்டுங்க. மத்ததெல்லாம் உங்களுக்கு தெரிஞ்சிரும். எப்படி எடுக்கிறதுன்னு தெரிஞ்சிரும்.
Okay. So see here I am going to fetch the input device. Before getting into push button, first we will go to slide switch. Simple. So I hope we have selected all the components. Arduino microcontroller, breadboard, one resistor, one LED, one more switch. Actually, I need one more resistor. Can anyone tell what is the shortcut to make the clone of the resistor? Control C, Control. That's all. Control C. Select the component and press Control C, Control. Copy and paste. You will get the new component. Okay. So before start doing the experiment, first we will power our breadboard. So I am going to take the 5 volt. I'm going to connect 5 volt. Then ground. If you have any doubt, please type it in chat box. So now we power the breadboard. We are going to take the components one by one. First we will connect the switch. So the switch may be a new component. So we will wait for some time. We will finish the LED. Take the LED. This is cathode. This is anode. Take one resistor. How to rotate the resistor? Go to this icon. Click. For every click, it will move 30 degrees. Okay. Keep the component in the breadboard and change the value. Can anyone tell what is the value we need to type it over here? Select ohm. What is the value of the resistor? 220 ohm or 330 ohm. Usually we will keep this as a resistor value. I hope it is visible for everyone. So what are the components we have connected? LED and resistor. Okay. So the cathode terminal of the LED, I need to connect it to the ground. That is negative terminal. That's all. So as per our problem statement, where I need to connect my input device, input must be in pin number 4, output is pin number 12. So you follow the same thing. Is it visible? Yes, yes. So I'm going to take the wire from pin number 12. Straight away I'm coming to the breadboard session. Yes, change it to. So the LED portion is over. So the cathode terminal is connected to ground. Anode terminal is connected in series with resistor. The value of the resistor is 220 ohm. At the other end of the resistor is connected to the 12th pin of our Arduino. Then the input device, switch. Can anyone tell what is the type of this switch? We have studied in the circuits, SPST, SPDT, DPST or DPDT. We have 4 options. Please observe the terminals. How many terminals are there? SPST, SPDT, DPST, DPDT. Can anyone type in chat box? If you want additional information, I will tell you one thing. You can consider this common terminal as an input. Then these two terminals as an output. See, this as the input, common terminal as the input. Then terminal 1, terminal 2 are the output. Can you tell me the type of switch?
SPDT.
Very good. SPDT. So even though we are having 3 terminals, we are going to use only 2 terminals. See, if I give input here, if I take output from this terminal, this is the off position. If you slide the switch from off to on condition, these two will be in contact. Now we will check this one with the help of our exercise. Okay. Now I gently kept my resistor, switch. Then we are going to pick the resistor to make the pull down configuration. So pull down configuration, first I will rotate the resistor, then I will type the value of the resistor. As we saw told already, the typical value will be 10 kilo ohm. Okay, 10 kilo ohm. So pull down resistor. Okay, so the particular terminal we need to connect it in the ground. Pull down configuration. What happened? The resistor, one end of the resistor is connected to the negative terminal. Okay. Another end is connected to the switch. Okay. Then from the same terminal, we need to take the output and we need to connect it into the. Don't worry about this connection. Once you draw, you will get familiar with this. So what happened? Forget about the switch. See, only the resistor. One end of the resistor is connected to the ground. The other end of the resistor straight away connected to the pin number 4. That means my pin number 4 is now in logic low. If I press the switch, what I need to check? If I press the switch, the logic level has to change from low to high. That means the common terminal, you must connect it into the logic high. That's all. The hardware connection is over. Now only the coding part. I repeat once again. Get all the components. Keep the Arduino board and breadboard and power the breadboard first. Then your wish. First, if you want to connect the LED, connect it. Else, if you want to connect the switch, you connect it. So whenever you connect the components, please keep the cursor nearby the terminal. It will help you by identifying the name of the terminal. So cathode terminal, I connected in the negative terminal. Anode, I connected in series with the resistor. Then another end of the terminal is connected to the output terminal. Okay, so the 12th pin of my Arduino. Then the 4th pin is input pin. So the 4th pin we have connected in series with the resistor and the switch. The common point only we are taking. Please observe. To correlate with the circuit diagram, from the common point only we need to take the input. Okay, then other end of the switch I am going to make it into logic high. Now we will come to the code part. So click code. In that you have the three options as we told already: blocks, blocks plus text, and text. In that we are going to choose only text. Click continue. Is it visible for everyone? Is it visible? So by default we will have this program. We will delete. And now we will start type the program one by one. Void setup. Can anyone help me what I have to type first? Left hand side, observe the diagram. 12th pin is output pin, 4th pin is input. These two we need to configure first. First I am going to type pin mode, pin number 4. I need to type input. Is it correct? So the command to make pin as input. That's all. Then immediately pin mode 12, input or output? It's obviously this output. So to make pin 12 as output. That's it. And what statement we have to include? So whenever we are using output device, by default it must be in a off condition. So I am going to write digital write off pin 12, low. So LED off. That's all. Now come to the loop session. So what I have to type, what are the things I need to do? I need to read the status of the switch. Then I need to check the condition of the switch. Then I need to make the logical change. We will do one by one. First, declare the variable. See, there are two options. First we can declare, then we can read. In any way you can type. See, these are all C program, C language. You are already aware of those things. Whatever the magic you can do it here. Okay. So now I am going to declare into switch separately. Then I am going to read the switch digital. It's not necessary. You need to use the same thing here. What I am going to type, you can modify it. Read the switch. Simply I am going to read switch. Then I need to check the conditions. What is the logical value I need to? So the logical statement I have to write. Please observe the difference. Here I am putting one single equal. Here I am putting double equal. So double equal means we are going to check the logical value. Single means we are going to assign the value to the particular variable. Okay. So I'm going to check the logical value as a high. Please help me. If high, what I have to type? If not, what I have to type? Please help me. Can you type it in chat box? If my switch is in on condition, what I have to type? I need to type digital write off 12, high. Very good. 12, high. Close the bracket. Don't forget to terminate it. Okay. So now true condition. Okay. True condition. If my switch is in on condition, if it is true, I will make the LED to on. make LED to on. If not, what I have to do? I need to make the pin to logic low. Logic low. So simply I am going to change the logic to low. That's all. LED off. Do you have any doubt? Please interrupt me. I will repeat once again. Void setup. What we have did? Pin number 4. See side by side. Pin number 4 input. Pin number 12 output. Then by default output is low. Then design the variable. Read the status of the input pin. See the here 4 means here also must 4. These are all the mistakes you will commit. Input 4 means you need to read the same pin. Then read the status of the switch. Then make it into logic high. If not, make it into low. Now you tell me what I have to do. Our program is ready. What we have to do? To execute the output, what I have to do? Please help me. We need to start the simulation. Okay, very good. So click code window, thereby the code window will get hide. That's all. If you click once again, the window will get appear. So it is a small window. If you keep both the things, you can't view the full hardware setup. So click code window. And one more thing, here you have one option, zoom to fit. If you click this button, it will get appear to the full window. Zoom to fit. See this icon. These icons are not easy in mobile phone. If you do with a laptop, it is good. Okay, now I am going to click start simulation. Now see the start time has to start count. Okay, then only it will give the indications that our program is right as well as it is in the run mode. Okay, then now you observe the condition. My LED is in off state. Sorry, switch is in off state. Therefore, LED is also off. Now we will change the position of the switch. Very good. If I made it on, LED also turned on. Success. But we are not happy with this. We need to again check the reverse logic also. Sometimes the LED may remains on for full time. Again, you change the position off. Yes, both the conditions are satisfied. Okay, do you have any doubt with this? If switch is in off condition, LED is off. If I make the switch to on, LED is also turned on. Is it okay? Any doubt? Tell me, else we will move to the second exercise. I repeat once again, pick all the components, make the hardware connections as per your requirement, then go to code window, type the required code, then simply click start simulation. Once you start simulation, immediately your program will get executed. Then check the required logic. Here my switch is in off state, so LED is off. If I make the switch to on, LED is turned. Okay, very good. Now I am going to stop the simulation and continue. So shall I continue, sir?
Toggle முடிச்சிடுங்க Jendran.
Yes, sir. Toggle. Yes. Now, see, please observe what new hardware we have included in the circuit diagram. Please type it in chat box. It's very much similar to our previous exercise. Only one component is new. Can you help me? Yes, it's a push button. Now you observe this video. What is toggle? Can anyone view this video? If not, please tell me. What you have observed? Whenever I am pressing the push button, the logical level gets toggled. See, if initially my LED is in off condition, if I press, LED is on. If I again press, LED is off. So this is what? Toggle. So in this way, we are going to toggle the state of the LED. And one more thing, at the end of the session, you have to give the application for all the exercise. Okay. Please remember, the first one is switch and the LED. The second one is toggle. 2 applications. Please think it over. At the end of the session, you have to tell where we can use this. Now we will come to the algorithm part. And one more thing. Here what we have to do, see, the very simple, the algorithm point of view, here I am going to use 8th pin as an input pin, 13th pin as an output. Why we are making these changes means you must know we can use any of the pin for our hardware configuration, not only 13 or not only 12. Earlier exercise we used 4th pin as output. Now we are going to use the 8th pin. So it seems that gives the idea that you have a variety of pins. You can use it any pins for any function. Okay, digital input or output. Now by the hardware's the schematic diagram, what we are observing, we have connected the LED in the pin number 13. So the output pin is simple, 13th pin. Input, we are going to connect our push button. Instead of the SPDT switch, here we are going to use the push button. Okay. So in the push button, I am going to connect the push button in the digital pin number 8. Then what we need to do, we need to remember the previous state, isn't it? So what is the previous state? You must remember the previous state of the two things, the switch and LED. If my previous state of the LED is off, and if I press the switch, what I have to do? If my previous state of the LED is in off condition, I need to make it into on. If my previous state of the LED is on condition, I need to toggle into low. The same thing we are going to see in the algorithm. See, first part, declare the initial conditions. That means what is the previous state and present state we can declare in the algorithm first. Then in the setup, as usual, you need to configure the pins. It is must. See, by default, all the pins as configured as an input. Please make a note of it. By default, all the pins are configured as an input. Even though it is configured as an input, it is good practice. We need to assign it as an input once. Then only by reading the program, which pin we have used as an input, you come to know. You are using as output, you must configure the pin as an output because that is not a default option. Okay. So as we discussed earlier, pin number 8 as an input, 13 as an output. Then make the pin 13 to low. This is the what we have discussed in the last exercise and all. Whenever you are using any output device, by default it must be in a off condition. That's all. The new thing is the declaration part. This we will see what we are going to declare it immediately. Program part. Please make a note of it. I'm going to, as I discussed earlier, I must know the previous state and present state of my switch and LED. If I know, I can toggle it. Without knowing the previous state, I can't toggle the value because I don't know whether my LED is in on state or off state. Without memory, I can't make the logical change. So here I am going to, for the switch, I am going to have the two things, present state and previous state. So first I am going to declare, first we are going to declare the switch present state as an integer. Then the second
கஜேந்திரன் வால்யூம் வல்ல அப்படி நிக்குது.
ஏன் சார்? கஜன் சார்?
I think disconnect ஆயிடுச்சா?
இல்லைங்க சார், லைன்ல காமிக்குதுங்க சார். நெட் ஏதாவது ப்ராப்ளமா இருக்கும் நினைக்கிறேன்.
கஜேந்திரன் இல்லையா இப்போ?
இப்போ இல்லைன்னு நினைக்கிறேங்க சார்.
திருப்பி கனெக்ட் ஆறாரா? கனெக்ட் ஆகிற மாதிரி தெரியுது. ப்ராப்ளி ஃபியூ மினிட்ஸ் வெயிட் பண்ணலாம். அப்படி இல்லைன்னா கஜேந்திரன் வந்துட்டார் நினைக்கிறேன் இப்போ.
எஸ் சார், ஜாயின் பண்ணுறது.
கஜேந்திரன்
ஹலோ சார்.
வாய்ஸ்
சார் எங்க ஸ்டாப் ஆமா சாரி சார், தெரியல சார். ஏதோட
கிளாஸோட பிரச்சனை
சார். அதுதான் சார், இது வைஃபை இல்ல சார், மொபைல் நெட்வொர்க்.
இந்த ப்ரோக்ராம்ல இருந்து நடத்தணும். இது ப்ரோக்ராம்ல
சார், ப்ரோக்ராம்ல இருந்து வந்து. எஸ் சாரி. எஸ் I will repeat once again. For me repeat, for you is the first time. Okay. Toggle. So whether the hardware portion வரைக்கும் முடிஞ்சிருச்சுங்க சார். ப்ரோக்ராம் தானே சார்? ப்ரோக்ராம் மட்டும் எக்ஸ்பிளைன் பண்ண போறோம் சார். ஹலோ ஹலோ.
அந்த இனிஷியலைசேஷன் வேரியபிள்ஸ்ல இருந்து ஆரம்பிக்கணும் கஜேந்திரன்.
எஸ் சார். ஓகே சார். இனிஷியலைசேஷன். Yes, good. We know the hardware setup. So here I need to read the status of the switch. Accordingly, I need to toggle the LED status. Okay. First, what we are going to do, the algorithm here, declare the initial condition, because here I am going to toggle the state of the LED. So therefore, I must know what is the previous condition, present condition. Based on that only, I can do the modification. Okay. So initially we are going to declare these states. Then immediately, as usual, in void setup, we need to configure the pins. So by default, all the pins were configured as an input pin. Even though it is configured as an input pin, we are going to assign it. Whenever you are using the hardware setup, please assign what is the input pin and output pin. If you forget in the void setup, your loop function won't execute. Okay. So first here, as per our hardware setup, we are going to configure the 8th pin as an input. Then where we have connected LED, we have connected LED in 13th pin. So configure the 13th pin as an output. Is it okay? Then immediately make the 13th pin into low. You may aware of that. Why we are including this one? Because if you by default, my output pin will be in off state. So therefore, I am making this statement. Then you see, so far we will start our program from only void setup. But here, before void setup, we have written something. What is this? This is called global declaration. Because this declaration portion, I am going to use it for all the functions, void setup as well as void loop. We will see what are those statements. First one, the first, please make note of it. The present state of the switch. So here just I declared the present state of the switch as an integer. Okay. Then previous state. Previous state, by default, I am going to set the previous state as low. Previous state as low. Then LED state. LED state also I am going to keep it as a low. So why we are going to keep these lower declarations means we are going to use this declaration into our program. Okay. Then please remember the initial state what we have declared. The previous state of the switch as well as the LED state is equal to low. Now we'll come to the void setup portion. I hope this is clear for you. 8th pin we have configured as an input. Then 13th pin we have configured as output. Okay. Then immediately make the pin to low. Is it okay so far? So in void setup, we made the 8th pin as input, 13th pin as output, and digital write as low. And few declarations above the void setup. While you read the loop program, you will come to know why we have declared those things. Sir, connected sir? Yes. Hello?
Yes, sir.
Yes. Okay, yes. Now we come to the while loop. This is the main algorithm. So what I am going to do, since I have an input device, I need to read the status of the switch first. Then I need to compare with the present state. Okay, the present state, what are things we are going to read is as a present state. Then I need to compare with the previous state. Then I need to make the logical change as a toggle. So for that, I'm going to read the status of the switch first. Then and also I'm going to consider the present state. By considering the present state, I'm going to compare. What I'm going to compare? See, first I'm going to compare if my previous state is low. You remember that by default we made the previous status low. So the previous state is low and present state is high. When my present state will become high means whenever I turned on my switch into logical high, that means first press. If I press my switch, immediately my switch state will become high. If this particular statement is true, I will keep my LED state, and again immediately I will check the LED state also. If it is low, I will keep LED state as high, else LED low. Then immediately after this logical execution, I will pass the value into my 13th pin. Accordingly, it will create the output. Then I will update the switch state. The algorithm may be a little difficult. Please observe the program, you will understand. Void loop. First, as we discussed earlier, why I am reading digital read of 8? Since I have connected switch in the 8th pin, I need to read the status of the 8th pin. I need to store it in the present state variable. Then, as for algorithm, I need to compare. I'm going to compare with the previous state as well as the present state. When my present state will become high, whenever I press the switch only, it will become high. So this is to time if you press, by default it will be in low state. So if this
கொஞ்ச நேரம் வாய்ஸ் வராம போயிடுது கஜேந்திரன். So the if statement திருப்பி சொல்லுங்க.
If statement. So, okay, I will repeat the if statement once again. So first read the status of the switch. Is it okay now, sir? Hello?
வருது கஜேந்திரன்.
Yes, sir. Read the status of the input pin and store it in the variable name called the present state. Then compare with the previous state. So by default, we made the previous state as low. Can you tell what is this and then? So we are going to do logical AND action. Okay. So logical AND we are going to do. That means these two statements must be in true. Then only the if statement will get executed. What is the if statement? Inside the if statement, again we are going to check the state of the LED is low. If it is low, make it into high. Else, make the LED state into low. So far what we have did means, we read the status of the switch and compared with the previous state, and we have created the LED state variable. Only two conditions. For LED state, we have high or low. We are not made any pin to logic high or low. Only the variable we made it. So what I have to do in next step, I need to pass the variable into my particular digital pin. So my digital pin, the 13th pin, I'm going to pass the variable called LED state. There are two conditions. One may be high or one may be low. If this statement is true, we will pass high into this state. Else, we will pass low into this state. Okay. Then we need to update the switch status. So switch status, by default it is low. Now the present state is, we are going to pass the present state into the previous state. The loop repeats again and again. Okay. I hope that this may be a little difficult for you, but by seeing the hardware setup, you will come to know how this logic is executed. Shall I come to the simulation part? Is it visible now? The screen is visible. Now I am getting to the Tinkercad. Is it visible?
Yes, sir. Visible.
Yes. Yes. What
Yes,
we are going
Gajendra.
to do? Yes, sir. See, here I will give you one simple step how to make the clone of the existing project. See, this is our previous experiment. What I am going to do, click setting, click setting. Here you have multiple options. The first one, what your properties. By clicking this, you can see the property of your project. Then the second option, duplicate. If you want to make the duplicate of my previous setup, click duplicate. If you click duplicate, immediately you will get a clone of your previous project with the name of copy of. Please observe here from where we took the clone, interface of switch and LED. So by the name copy of interface and switch LED will get appear. So now I am going to rename this as simply toggle LED. So okay, toggle LED. So all the existing components I have in my workbook, what are things I need to change alone, I'm going to delete. So okay. So LED configuration is same. Instead of this slide switch, we are going to include push button. So can you view the push button? Can you view the push button? Push button have 4 terminals. As I told already, have 4 terminals. Sir, is it clear? The visible? Hello?
இருக்குங்க Gajendra.
Yes, sir. As I told already, push button have 4 terminals. See, if you bring the cursor nearby this 1A and 2A. Here 1B and 2B. So sir told simply diagonal. If you connect it diagonal, it is easy to make the hardware connection. Very simple. See, if I give input in 1A, I will receive the output in 2A. Please make a note of it. As for this switch, this labeling, if I give input in 1A, I will get output in 2A. But what is the beauty of this one? This 1A and 1B is always in connection. 1A and 1B always will be in NC. It will be in connection. Similarly, 2A and 2B is NC. Always it will be in connection. Whenever I press the switch, this 1A will get connect with 2A. Similarly, this 1B will get connect with 2B. We will see how it works. Now, I'm going to delete the existing switch connection alone, and I'm going to include the push button. Select the resistor and move it somewhere. Bring the push button. So whenever you connect the push button, please use this middle portion. Okay, in between the top layer as well as bottom layer. So one end must be in top layer, another end must be in the lower layer. Okay, then so simply this is input, this is output. So I'm going to select the resistor and drag the resistor, and I'm going to keep it over here. So by default, we are going to make the resistor to pull down configuration, pull down. So black. Then where is the common point? This is the common point. From the common point, I need to take the output. So I can take the output from here. I can take the output from here. Else, I can take the output from here. Else from the top, because these two are always be in contact. Okay, so I can take the output from here. Where we have to connect input pin? Can anyone tell the input pin? I hope it is 8th pin. Am I correct? Input pin. Input pin is 8. Input pin is 8. Output pin is 13. So input pin 8. Then in the push button, output side we have connected. The input we need to make it into logic high. Very similar to the previous exercise. Very similar to the previous exercise. Only the hardware connection is little different. Same. I made the LED to resistor to logic low. Then the other end is connected to the push button from the same terminal. These are all common connections. From the same terminal, I have connected into the Arduino input pin. Okay. Then the other end of the push button is connected to logic high. That means whenever I press the switch, this particular pin will receive logic high. Whenever I release the push button, the pin will receive logic low. Okay. Then what else is pending? Only the LED connection. LED connection. So LED, I need to connect it in pin number 13. Pin number 13. Okay. Hardware setup is okay. We have connected successfully push button as well as LED. Please ensure the pin number 8 and pin number 13. Now we will get into the coding part. So this is our previous one. Delete this. Yes. Before void setup, what we need to type? Can anyone assist me? Void setup, we need to do the global declaration. So is it visible, sir? Shall I continue, sir?
Visible, Gajendra.
Yes, sir. In global declaration, we are going. In the global declaration, we are going to declare the switch state and LED state. As we discussed earlier, I am going to type switch present state, switch present state, switch present state, then switch previous state, SW previous state. I'm going to assign the value for the previous state as logic low. And what else? Then LED state. So LED state also equal to, by default, I'm going to keep it as low. So the global declaration part is over. Then void setup. In void setup, what I have to do? You are very much familiar with this. I want you to repeat again and again. Pin mode. Please compare your hardware. 8th pin is input. So immediately type 8, input. 8, input. Then pin mode 13. 13th pin as output. So 13, output. Then immediately digital write off output pin, logic low. By default, make your output pin as logic low. That's all. So global declaration setup is over. In void loop, what I have to do? I need to read the status of the present state. Then I need to compare with the previous state. Accordingly, I need to make the logical change. So whatever the variable you have declared, you need to use the same variable. If you commit any syntax error, it won't work. Okay. So I'm copying the variable switch state equal to. Now I am going to read the status of the switch. What is the command? Digital read off. What is the pin number? 8. Very good. Then condition state. If my previous state of the switch, so this is our previous state. We are going to check if my previous state equal to. Please observe these two differences. In second line, we assign the value. Now we are going to check the logical condition. So equal to low means logical function. We are going to check the state of the particular variable. If it is low, and so see this is logical, and we are going to compare with the one more statement that is called present state. So if my present state is high means what? My switch is in on condition. Please observe my previous state of my switch is low, and as well as I made the switch to on. If I press the switch, immediately what will happen? My present state will vary. How it will vary? I am going to read the status of the pin and I am going to store it in this variable. Therefore, it will become high. If I press the switch, it will become high. Then also I need to check the status of my LED, because in previous state it may be in on condition or off condition. Accordingly, I need to toggle. Roughly, I can toggle the state of the LED. So again, one more condition, I am going to check the state of the LED also. If my state of LED is low, that means default condition. Default condition. If it is low, what I have to do? I need to toggle the state. Simply toggle the state as high. There may be another option. If you keep on run the program, the state may get vary. So therefore, if else, give the opposite state. Yes, low. Is it visible? Shall I continue? Is it visible for everyone? Yes, sir. Okay. So we read that.
It's visible.
Yes. Now, see, now we check the condition of the switch, then state of the LED. Since I need to toggle the state of the LED, I need to check the previous condition. Accordingly, I am going to create. So far, we assign only the variable name. We didn't pass the value to our digital pin. Now only we are going to pass the value into our digital pin. Where I need to send, whether I need to send the value into pin number 8 or 13, please help me. Which pin I need to use? Which pin I need to use? 8 or 13? Yes, very good. It is 13. Here I am not going to write the value as logic high or low as like the previous exercises. Here I am going to give this variable name because this variable get changed based on other program flow. Okay. Then at last, what I have to do? I need to update the state of the switch. So therefore, the previous state, now I'm going to update the previous state. By default, it will be low. No longer it is low. Once the program gets executed, it will take the previous state is equal to present state. Previous state is equal to previous state is equal to present state. Is it clear for everyone? Then check the brackets. Void setup, one opening, one close. Then void loop, if function, one loop, then here. Is it okay? I will start simulate this one. If you have any error, the error window will get appear. Okay, start simulate. Yes, successfully compiled. Now we will come to the hardware part. Can you tell me what is the state of the LED now? Whether it is in on state or off state? Obviously it is in off state. Now I am going to press the push button. Very good. See, I released my finger. See, it remains on. When it will get turn off? Tell me anyone please. When it will turn off? When it will get turn off? If I press once again. See, if I press once again, my LED gets off. Again, if I press, likewise, keep on, I can change the state of the LED by pressing the push button. Is it clear so far? If you have any doubt, please call me or type it in. See, kind of first statement, 2 push buttons, 1 LED. If you press any one push button, LED has to glow. Okay. The second one, staircase wiring. You are aware of this one. 2 different locations. You need to control this lamp. Don't do any AC wiring and all. Do with only Arduino board push button, only in Tinkercad. Okay, and one more precaution: if you type more number of experiments will come in website, don't try anything without our guidance. Okay, whatever the task we are giving, do alone. Do that experiments alone. Okay, don't handle with AC supply and all. So, humble request.